Hey, welcome back. We're still in Chapter 1 Exponents, but now we're on Lesson 2. What is Lesson 2? Lesson 2 is, what is a monomial? What is a monomial? And the target is going to be to learn the definition of a monomial, but also the parts of a monomial. So target, we're going to learn and understand monomials and the parts of monomials. And spell it correctly. Monomials and its parts. Okay, what could I be talking about there? Well, first of all, let's get a definition for a monomial. A monomial is a number, like 6. 6 is a monomial. Or a variable. So x is a monomial. Y is a monomial. Or the product of a number and one or more variables, or the product of a number and, look at this, I made my and wrong. Thank goodness for a whiteout, because, mistakes happen. And one or more variables. And this is the part that it's we'll talk about more later. With positive exponents. Exponents. So let's get some examples. So I said that 6 could be a monomial. Any whole number, 5,280, that's a monomial. I also said that x is a monomial. Y is a monomial. Any variable is a monomial. And the product of a number and a variable. So 6x. And any number and a variable, 5,280 and xyz. I can have more than one variable. I could have 6x and 6xy. All of those are examples of monomials. Now, there's some things that are not monomials. Not monomials. So what's a not monomial? 6 plus x. Blech, not a monomial. Our definition talks about product, and product is multiplication, and that's addition. So that is no good, not a monomial. Or if I have something with a negative exponent, like say x to the negative third power. I can't have a negative exponent. It says with positive exponents. Now we're going to do something with this later to make it into kind of a monomial, but right now, blah, no good at all. But what if I have a fraction? What if I have something like 2/3 x? That's a monomial. It is. It's 2/3 times x. But what if it's written like this? 2x over y. Oh, it doesn't say anything about division up here, does it? No. But I can rewrite this as 2x times 1 over y. I could rewrite that as multiplication. And then, guess what? It's a monomial. Okay, so there's a bunch of different ways to write monomials. And these are very different. What's different about them? Well, for instance, the base is different. This has a base of x, and this has a base of 2 times x. This 2 is not part of the base. What this says right here is 2 times x to the 3rd power. Now, if I were to write this out, I would write 2, and I use a big dot for multiplication, times x times x times x. That would be the expanded notation. This is a monomial, and that is still a monomial, and that's the expanded notation. Now, this blue number 2 right here, that's called the coefficient. And that's the number you multiply times the base. Coefficient, number multiplied times the base. It's not the base, but it's multiplied times the base. Now over here, the base here is 2x. So my base is 2x, and that is all raised to the 3rd power. So if I was to do that in expanded notation, it would be parentheses 2x times 2x times 2x. The base is 2x. Over here, my base is just x, but here, the 2x is the base. Now, let's take a look over here. For each monomial, we're going to identify the coefficient, the base, and the exponent. So for this first problem, the coefficient is 1/2. Make this big enough so you could see it. 1/2 is being multiplied times the base, m, and my exponent is 4. For this one, my coefficient is 3, my base is a. Wait a second, you're not showing us anything. Here we go. My coefficient is 3, my base is a, but I don't seem to have an exponent. I can rewrite this as 3a and give my base a the exponent 1, because there's 1a here. So my exponent there is going to be 1. Let's take a look at this one. My base is x. My exponent is 2. And the 7 8/10, that's the coefficient. The whole thing, 7 8/10. Now this one is another one of those tricky ones that I'm going to rewrite. I'm going to rewrite this as -1 times y to the 6th power. I'm even going to put a little dot in the middle here. My coefficient here is -1. Even though there's no 1 here, it's implied. It's kind of like in Viso math. So I have a coefficient of -1, a base of y, and an exponent of 6. So for the rest of the problems, I'd like you to try them. I'd like you to write the simplified form and then using the vocabulary, coefficient, base, and exponent. We learned base and exponent. The only new word is coefficient, and coefficient is the number that you're multiplying times the base. Now, good luck. turn off the video and do these problems. When you come back, I'll do them with you. Okay, welcome back. Let's look at this first problem. Here, I have a base of -4. 1, 2, 3, -4. And that's to the exponent 3. But I have another base, m. And that's 1, 2 to the second power. I have 2 bases and 2 exponents. That's interesting. How am I going to write that? I'm going to use the number -4 to the third power. I could actually multiply that out. I could take that number, parentheses, -4, parentheses. Remember that arrow that pointed up, the caret, to the third power, and get a number, -64. That's what I'm going to use as my base. So I could actually rewrite this as -64 m to the second power. Now I can't do anything with the m because it's an unknown, but I can solve the -4 to the third power and get a coefficient of -64 and a base m and an exponent 2. Ha, that was a tricky one, Bono. You start with the hard ones. I'm going to do something similar for this. I have 2 bases here. I have I have positive 2/3 to the second power. And then I have the variable p, and I have 1, 2, 3, 4 of those. And I am going to pause my video right now and come back to it because I have to teach a 4th period class. Take care, guys.